Morning and welcome back to another lecture for web and mobile systems. In this discussion, we are going to continue to discuss about the last pieces of puzzle that we need to kind of learn in order to complete our meme generator app that we were developing using React JS. So to quickly recap, in the last class, we had essentially gone over the details of how to perform state management using the useState hook in React library that allows React to have a control over the variables that are declared within the different custom components that you will have in your React app. Okay. And in addition to that, we also talked about React forms, the different elements that are used within React forms, which is very similar to HTML forms, but of course with subtle changes with respect to reserved keywords and stuff like that. And in React forms, we also talked about event listeners and how we can implement event listeners within the React environment, right? And that allows us to kind of implement user interactivity for our React applications and then kind of transform any type of static React app into a more dynamic React app that allows you to take either input from the user, change behavior of your application based on those type of interactions and the events that are triggered by the users, and then change the state of your UI and stuff like that. So at this point, in order to complete the meme generator app, we are almost 2/3 there, right? So we have covered 2 of the 3 pieces, essential pieces that are required to kind of finish off our application, right? So the last piece of the puzzle is to basically understand API calls, okay? How API calls are performed or how you can integrate API calls within your React application. And this is essentially a useful tool because if you are writing a React application that has some sort of connection to a server-side process, right? A server-side script or a server-side backend that is running, which either you develop or you are essentially trying to connect a third-party backend, which kind of gives back some sort of data if you incorporate some kind of read method, right? So those API calls are essential, and we need to understand how to integrate those API calls within our UI as well, right? And the way we do it, we cannot do it as is. We cannot just, make a call to those backend APIs. We need to do it in addition to another React hook that enables us with a certain functionality, which we will discuss shortly, that is known as the useEffect hook. Okay, and this useEffect hook is also a part of the React library itself, just like the useState hook is. So when we are going to call it, we can either import the entire useEffect object into a particular object within your file itself, or we can call it by using the React object, which we always which we always import, and then we can do React dot useEffect hook, right? So this is a hook and this is a functional component, so it will be kind of treated as a functional declaration as well. So question is, or the motivation behind learning useEffect hook is what we have to first of all understand. And the motivation lies within the fact that when you are using the useState hook, the purpose of this hook is to allow React to manage the data values that are declared within a functional component. Okay, so this is basically the motivation of the useState hook. So if you declare any variables within your custom components, custom functional components, for example, let's say if you have a header.js where you are declaring the name of the user who is using your particular application, right? And you want to keep a track of the different users who come along and then they use your application. Or depending on using, let's say, a React form where you can have input text elements, input usernames, and all those kind of things, right? So you need to keep track of the values that of those form fields are changing, right? And then basically allow React to re-render the UI if there is a change that is taking place, right? So React needs some sort of control over the behavior of the objects or the data values that you declare within the functional components, right? So to enable that, we use the use state hook, and we talked about the different syntax, or not the different, but basically the syntax or the breakdown of the syntax of the how use state use hooks work, right? But if you compare this scenario to, let's say, an API call, right? So this is not a data value, or this behavior itself is not something that is owned by React, right? So this is not happening within your React JS environment. That is the first thing that you have to kind of essentially keep in mind, that this is a behavior. An API call is a behavior which is outside the control of your React JS library or your React JS application that you are developing, right? So you can think in terms of having something like your React JS library to be kind of like a black box. You can think of it that way. And when you're doing an API call, basically you are asking for a connection. And then depending on the type of API call that you have, that is whether it is a read request or a write request, different behaviors will take place, right? So if it's a write request, there isn't much of a concern there because you're essentially sending data to wherever the third-party API or wherever your server is, right? So here we are essentially mostly focused on the read request itself. That is when you're bringing something into your React application from outside the React application's environment, right? So essentially what we're talking about is, let's say if this block is basically your React application, right? And within this React application, you essentially have your app.js here, which is your main area where you are kind of consolidating or bringing together all of your different UI logic. And then you can have maybe a custom component 1 here, a custom component 2 here, a custom component 3 here, and so on and so forth. And all of this have some sort of a hierarchical relation between each other. So that means, let's say, within custom component 1, you call custom component 3, and then custom component 1 and custom component 2 are essentially referred to or invoked within the app.js. And then app.js is then after that fed into, let's say, index.js. So typically, this is how the structure of a React application is going to look like, the fundamental structure of a React application, right? So from within this scenario, now let's say you make an API call within this particular custom component, okay, just as an example. So what happens here is that if this is the boundary of your React application itself, in this black box, and if you make an API call within this custom component, then this custom component is essentially making a request to an environment which essentially lies outside of this particular domain, right? The domain being the React application's domain. And your API could be any kind of third-party application, as we discussed earlier. It could be your own server-side backend, which is supported by a database application, and that is how the data is basically generated and sent back to you. So you make a request here, okay? And then that API, depending on whether it is functional, whether making sure that there is no connection issues and stuff like that, it will send back a response, okay? And that response needs to be captured within this functional component. And then depending on how the state of the data changes there, like which is being sent as a response by the API, this component will be rendered on your UI, on your browser when it loads, right? So essentially, the data that is being sent by the API, this is not something that is declared within the custom component, right? So you cannot essentially make use of the use state hook. You cannot use this in order to keep a track or a control of the data that is coming from an external party, okay, or that is coming from an external API call. So there needs to be another way that gives React some ability to control when it needs to render the data that is coming from an external API, right? So essentially, if let's say I make a fetch request, okay, so that is one of the methods that we use generally in order to connect to an API. We use this method called fetch, and within fetch, we provide the URL of the API which we are trying to connect to, right? And we are requesting data from, okay? So essentially, when we do this fetch URL application, it sends back some data. And typically what you do whenever you receive data from anywhere and you have to kind of manage it, so to speak, within your application, you're going to put it inside some sort of a container. That container could be an array. That container could be an object, a variable, depending on the nature of the data. It could be whatever data structure that you want to use, which is the most suitable for that particular situation, right? So now we all know for a fact that whenever the state of this container changes, and remember this container contains data which is not declared within the custom component itself. It is coming from an external source. This is the first thing that you have to keep in mind, okay? So now, if the state of the container changes, and by that I mean, let's say when you declare this container within your custom component, at the very first stage, it is empty, okay? And then when this fetch call executes, that is, it is successfully able to connect to this URL that you have provided, and then that API responds back with the data, and the data comes into your React environment, which is this particular black box, and then it is stored in the container, right? So that means there is a state update. All right. So now we know for a fact that every time that there is a state update, as we discussed in our discussions of React state management, that is every time the state of a particular data container or a variable object, whatever it may be, changes, then that change needs to be rendered on the UI, especially if you are referring to this container within the return statement of your custom component, such that it needs to be displayed back to the user through the web browser, right? So if there is a state update, this will require React to re-render our UI, okay, such that the changes, that update that has taken place within this particular container can be displayed back to the user, if that is the logic of your application, right? So now, since this is not, this process of state update cannot be connected to the useState hook, because this data value is not something that is generating from within the boundaries of the React app itself, it is coming from outside, there has to be another method which wraps this entire process that is kind of written out in this blue ink, such that React knows that, okay, I need to update my UI because there has been a state update, right? So how does React do that? And this is the solution for that people have come up with, is to incorporate this React hook that is known as useEffect, okay? And that essentially enables the process, or that gives the power to the React library to kind of have some level of control over deciding whether or not this fetch API needs to be called again, or whether this fetch API received data again, because it could be a continuous process. There could be a stream of data. For example, let's say if you're working with some sort of a sensing application, right? It is sensing temperature or humidity, and let's say if the logic is, if that temperature or humidity crosses a certain value, then you need to start your air conditioning unit of your house, right? Something like that. So that is a program that you wrote, a very simple example, right? So the React will be getting the data, let's say every 15 minutes, 30 minutes, 1 hour, however you specified this fetch URL is supposed to work, right? So there will be a stream of data that will be coming. So React needs to be aware of that there is a stream of data that is coming, and it needs to keep on checking whether this fetch URL method needs to keep on executing until a point where you have specified a certain logic where it stops, right? So how long should it keep on doing it, right? When should it keep on reloading its UI, so to speak, right? Those are basically the actions that you can specify or tell React using the useEffect hook, okay? And typically the structure or the basic syntax of a React useEffect hook consists of two different parameters. Just like in the useState hook, to recap real quick, what we discussed about the useState hook, so that you can connect to the structure of the useEffect as well. When you do a React.useState hook, okay, it takes a function, a callback function, as an input parameter. Okay, so not a callback function, it basically takes the initial state of the object or the data container that you're trying to initialize, and then it gives us back essentially an array containing of two different indices. The first index is basically the container, which will contain the value or data value that will change and so on and so forth, right? The initial value as well as the data values that will be updated will be kept within this container. So anytime you want to access the most up-to-date value of your state, then you will be referring to this container and not wherever this initial state is basically in, right? And then it also gives us back a setter that allows us to update the values within this container. So that will be basically a function, but we name it as such. But you have to remember the fact that the second parameter, which is returned within the array, is essentially a function call, right? So whenever we need to call this function, we need to pass in arguments to this function, which will be the updated value of the state that we are trying to track, right? So this is basically the skeletal structure of working with the use state hook. Now, if you kind of compare that to the useEffect hook, you need to call it similarly. That is, if you do not make an import statement that individually extracts this particular hook from the React library, then you have to make a call to the library itself first, then use the dot object or the dot parameter, and then you need to call the method itself that you are trying to refer to, right? So this is a more better way to do it for beginners, since it kind of reminds you that this is a part of the React hook. Once you get more accustomed to what you're working with, then you can do something like React import, and then within the import, you can do useEffect, and then you can just say from React. Okay, so if you do this, then you don't have to write React.useEffect. You can simply just call useEffect as is, because now you have imported it within this particular object here, right? But as starting off, when you're initially working with it, just write the full declaration so that you can understand that, okay, this is a part of the React library itself, right? And what useEffect hook takes as input are two parameters again. Okay, so this takes two parameters as inputs. So the first parameter is going to be a callback function again, and this callback function essentially will wrap the logic of that external behavior which you are executing. So in this particular case, everything that happens from here to here, right? Not the environment of the API itself, but this process here, that is, you're sending a request to the API and you're receiving a response back from the API with some sort of data, which needs to be stored in some sort of a container. And then you essentially need to make a decision whether to run this process again or not. That is, whether this should run once, whether this should continue running infinitely, or whether this should run for a limited amount of time, right? So this is the logic, or this is the external behavior, which will be wrapped within the body of the callback function, which will become the first parameter of your useEffect hook, right? Now, the second parameter generally decides how many times should this external behavior be executed by React. Okay, and there are certain options here. That is, this kind of behavior of making a request to the API can run infinite number of times. There is no limitations to how many times it will execute, or maybe it executes just once when your app loads. Okay, it could be a behavior like that, depending on what type of API are you kind of sending a request to, and what is the purpose of that API. Or it could run for a limited amount of time, or it could run based on a certain logic that every time, let's say, your 10 seconds passes, you are going to run this request again. Like for the example of that temperature data that we were talking about, if you know for a fact that your temperature data is going to kind of send data every 15 minutes, then essentially the requirement for your useEffect to execute is after every 15 minutes, because that is when you know that if you send a request, there will be a new data that will be sent back by the API, whatever it is that, wherever it is running, right? So the second aspect is what we call as a dependency array. Okay, and that dependency array can consist of multiple values which will govern the execution of this callback function. Okay, so again, I repeat, there are two parameters. The first one is a callback function. which will wrap the logic of the external behavior that is being connected to your React application. In this particular case, it is basically a call to the API and then whatever data the API sends back. Okay. And then the second parameter is technically called as a dependency array. So let us put these third brackets here. And what the dependency array controls is basically how many times should this logic of callback function, or the logic that this callback function is wrapping, should be executed by React. Okay, so through this dependency array and through this setup, essentially, is how we give React the ability to control the external behaviors of a React application. Okay, so it does not have any direct control over how this API is going to work. It does not know what the API is doing because this is completely outside of this React boundary, right? But however, once this connection is established or this logic has been written out, you can, using the useEffect hook, control what is going to be the effect of this external call on the React API itself. Okay, so that is basically how this particular method is set up. Okay, or that is how basically this hook works. This is the motivation, the objective, and how you would want to implement this particular operation. All right, so let us go ahead and look at a simple implementation of an API call, and then we will kind of bring all of this together into our meme generator app, and then basically finish the development of the app in hopefully today's class. Okay, so going forward, we don't need all of this. This is a different thing that I was working on, which was for cloud. So this is our working application, and this is basically, we are in the correct directory. We want to make sure that. And then what we want to do is set up our app.js first. That is the only thing that I want to open for the time being. So here, we only have a call to the React's form tutorial that we were working on from the last class. So let us go ahead and start the server using npm start, making sure that we are in the correct app folder. That is important. And the first thing that we are going to do is basically make an API call to what is known as a Star Wars API, right? So there is an API for Star Wars, which consists of different information about who are the different characters, what are their features and attributes that are associated with it, and those kind of information. So we are going to do a very simple thing, which will help us understand this structure that we were talking about and how it connects to all of this logic that we discussed, overall logic, basically by implementing that Star Wars API call. And once that is done, we will kind of mimic that behavior within our meme generator app, and we will make an API call to a pictures repository for different memes that once you call it, it just sends you back an array of objects consisting of different meme images and their metadata description, which can then be integrated to our application, right? So that is essentially the goal that we are moving towards. All right, so this is our development server as we had built last time. So we had the header component here, and we have the React form component here, which is controlled by our use state hook and our event listeners. So we're going to minimize this for the time being because we don't need this. And we are going to kind of comment out the React form tutorial call within the app.js environment because we don't want to work with that no more. Okay, so that will give us some warnings because we are not using this import. So if we save this, that will take care of the warning itself. So all we have to do now is just define another custom component here. So within the my app directory, I'm already here. So I need to move to the src directory. And then within the src directory, I need to go to my components subdirectory. Okay, and here I need to create a new component, and we can call this React API tutorial.js. Okay, there is some bug with my terminal here, so it's not showing up some of these stuff here. I don't know if you guys can see it through the screencast or not, but I for sure cannot see this. So, but it's working, so I'll just let it run for the time being. So once we set up the new custom component, we have to kind of populate the boiler code. So the boiler code will be a React functional component with an export statement. That is the snippet that we are dealing with. And this will essentially generate all of the different actions or all of the different boilerplate codes that we need for this. All right. So again, remember the first motivation behind using the hook useEffect is to kind of allow React to have some control over the external behaviors, that is behaviors that are external to your React UI. Okay, that is something that is you are not declaring within your React UI. It's a process or it's an operation that takes place outside of the React UI. And then once it comes within your React environment, how do you give React the ability to control its behavior? That is the main objective and motivation behind using this particular hook. All right. So the one way where you can kind of remember this, I don't think I have talked about this, but every time we generate this boilerplate code, we write our functional component. We declare it as a function here. The return statement consists of our JSX syntax, which is what will be rendered on the browser itself. And then we have an export statement, right? Sometimes you will see some codes which instead of writing a separate export statement, they will write export default and then just write the function declaration as well. So that is basically a way of writing both the export statement as well as the functional declaration at the same time, right? So don't get confused by those syntaxes. So what I essentially mean by what I'm trying to say is that sometimes you will see this happening, okay? So, and then you will not see this particular statement. So both of these things are the same thing. You can do it separately. You can do it in a single line, depending on your style of coding, right? So I will just leave this because sometimes what happens is that in certain scenarios, you would want to export more than one component from a given custom component, right? There are scenarios where you can have multiple objects. There are scenarios where you can have the multiple functions that you need to bring out from a particular custom component. So in that scenario, it is better to just have a specific subsection where you're dealing with all the exports rather than kind of inlining the export declaration at the same time, right? But there is nothing wrong with doing it. If you can manage it, all the power to you. All right. So, all right. So what are we doing here? So whenever you are declaring your useEffect hook and your applications, you are going to do it within the component. Okay. Remember that. But outside of this return statement will only have anything that has to do with your hooks and other declarations or any other logic that you're trying to write, which is in JavaScript as such. All right. So our goal is here to make an API call. And the API that we are using is API call to the Star Wars API. Okay. And this will send us data. So we have to receive the data and control through state management. All right, because remember this is a data that will come within this particular custom component. So once it does arrive within our custom component from the API call, we have to save it somewhere. And the moment we say that we have to save some values within the custom component, that goes back to state management. Okay, so the first thing that we have to use is basically state management in order to set up the data containers, which will receive the data that will be returned when a call is made to the Star Wars API, right? So that is the first step that we have to take care here. So I'm going to call on React.useState. Now, notice here within the useState, as we discussed in this particular declaration, what we provide is the initial state of our data container. What should be the initial values? So we are basically declaring and initializing our container when we are making a call to useState itself. Now, since we are making a call to a location that is outside the React app, we don't have any initial values. If you want to provide any initial values, that is fine. But if you do not know what your initial values is going to be, depending on whether you, based on your understanding, whether it returns an array or whether it returns an object and stuff like that, you can just do an empty declaration within your initial state. So here, I'm just going to leave it as an empty object. Okay, just having two curly braces, that is the object declaration in JavaScript. So we're just going to leave that empty, right? And we know for a fact that this is going to return us two different values. Well, it is going to return us an array with two indexes, but we are going to destructure the array and create individual variable names or individual labels outside of the array. So every time that we want to refer to those indexes, we don't have to use the notation of array and then within third brackets 0 for the first index, and then array within third brackets 1 for the second index, and so on, right? So here we are going to destructure the array, and the way to do that is just to write the variable name within the third brackets itself. So here we can say that the name of the container is Star Wars data, and then the callback function or the setter that is returned will be written as set Star Wars data. Okay, give it a space and assign it to this particular variable, and then we have set up our state management. Okay, so the next question is how to work with the Star Wars API. All right, so in order to make a call to the Star Wars API itself, we are going to, okay, so here we will say make a call to Star Wars API. All right, so here, what do we need in order to get this running? What are the different recipes do we need? Well, we need a method that will essentially allow us to make that call, method that allows us to initiate the call. And then the second parameter that we need, which needs to be passed as an argument to this method that we will be using, is basically the URL of the API. So even if you have a server that is developed as a REST API, it will have some sort of an API. And typically when you develop your front end using React and back end using whatever, right, you basically are developing what we call as JSON APIs, which is similar to what we are discussing right now, because all of the data exchanges that takes place during this request response cycle to an API call takes place in a JSON format. That is how the data is packaged in the JSON notation. So it is also helpful at this point of time, if you're not familiar with what JSON is and how it works, to kind of refresh that again from our JavaScript fundamental discussions that we had before, right? So the method that we are going to be using here, and there are different methods that is there, but the most easiest one is the fetch method, right? But the simplest one is basically the fetch method, which establishes a call. Within this fetch method, as a string parameter, you are going to specify the URL of your API, okay? And then this is basically an asynchronous method. And what I mean by that is that when you are fetching, when you execute this particular method, right, or when this method gets executed, then a call is initiated to wherever this URL is hosted, right? Some sort of server is hosting that particular URL, right? So there are two options for your UI at this point of time. Either you wait in a serial dependent fashion for that external server to respond back to your call, which may or may not happen, right? Or you can run this asynchronously. That is, whenever this is executed, you just add on or kind of chain other methods that is going to kind of express the contingency plans of what happens when you do receive a response from this particular method call. And if you do not receive a response, if you receive an error from this method call, then what you are going to do. Okay, so the way we do it when we are using the fetch method to chain all of these different next steps when this particular function call or this method is executed is through another method that is known as the then method. So you can say then, and here logic of what to do is expressed after the invocation of the API call. So we can write a bunch of then statements. So you can say, if you have multiple steps that you have to execute, and each step is dependent upon the execution of the previous step, or maybe mutually exclusive, depending on the logic of your application, then I can write another then here, and I can say step 2 to execute after API call. And notice that these then statements basically wrap the successful behavior that needs to be executed after the API call, okay, and not the unsuccessful. So there will be another chaining that you need to do at the very end for unsuccessful API call, which is to basically catch if there is an error. So here the catch will take some sort of a callback function in order to execute the logic if this API call wasn't successful. Okay, so that is what we need to keep in mind. All right, so understanding this, we are going to make this execution. So this is the logic that we need to execute within useEffect, right? So here we said there is going to be a callback function which is going to wrap the logic of this external behavior. So this external behavior is established by this particular syntax here. That is, you make the fetch call, you chain it with the logic using the then method of what to do if there is a successful call, and then you finally end it with a catch call where you specify that if this fetch URL execution is not successful, then how should your application behave, right? So this is the external behavior. This is the logic of the external behavior. And this will basically become the body of the callback function, which will be executed or passed as a first parameter to our useEffect hook. Okay, so that is how we are building on top of each other. All right, so when you make that useEffect hook call, there are a few things that is going to take place. Okay, and I'm going to just bring all of those notes here instead of typing that one by one. So essentially, this is just the outline that we already discussed, right? So we have a callback function, we have dependency arrays. All right, this will manage. So this is called a side effect. This whole application behavior that we're talking about, or the behavior of the external entities on our React application, it is known as a side effect because it is coming, well, from outside the React app itself, but you can interpret it as long as you understand the technical basis of what is happening. Okay. The important thing is that when does a useEffect call takes place? That is the important thing that you have to keep in mind. So for that, we need to kind of revisit this guy here, and we need to open a new kind of canvas in order to understand this, right? So what is the order of execution within a React application? So if you think about the structure of any kind of custom component that you define, right? So if this file is your custom component or the custom component that we're working with, right? You do all your import statement and stuff like that, but then you define your functional component here, right? So you have a functional component, and then the body of this component begins here, and then you have a export statement after that. You have all your import statements here and any kind of variable declaration that you may want. And then within this function body, you have essentially a return statement. And this return statement consists of your JSX syntax, that is your HTML-like syntax, and this will be rendered on the UI. And all your hook stuff, that is if you're doing your state management hook or your side effect hooks, okay, these are basically declared between the declaration of your function itself and before the declaration or expression of your return statement, right? So what is the order of execution? When this is loaded by the React server and this is rendered on the UI, how does this execute? Well, the first thing, when you mount this component, that is the technical word that people use, that when your component is mounted onto your UI, essentially, the first thing that executes is the content within this return statement. Okay, and after that, all your state hooks and your side effects hooks are initialized. So the first time that this particular custom component loads, it will render all of the different JSX pieces that are present within the return statement. Then it will go to this particular area here. It will encounter a state management hook. So it will initialize all the states that you have specified. And then let's say it will encounter the useEffect hook that we have specified or we are going to specify here. Okay, so once it encounters the useEffect hook, it will, without checking anything, execute the logic of the hook in the first attempt. All right. So that means whatever or this API call that we have specified here or that we are going to specify within the body of the callback function of the useEffect hook, this will execute once without any kind of conditional statement checks. All right. So once it executes for the first time, it will bring the data, and we are setting up for the data to be stored in this particular container. And since this is being monitored by state management, anytime the state of this container changes, we will re-render our application. Okay, essentially, if this is involved in any operations within our return statement, right? So we know that for a fact. Now, the next question is, should you run the logic that is wrapped within the callback function of your useEffect again? So after the first time, do you want to run it again or not? So the way that behavior is controlled, that is whether you should run the call to your API multiple times, and if multiple times, then how many number of times, then that logic is governed by the value that you specify here in the dependencies array. So this thing plays a very important role. If you leave the dependencies array empty, okay, so that means if the dependency array is empty, let me write this down real quick. So if the dependency array is empty or not specified at all, then API call keeps running, okay, indefinitely. There is no way for React to control that behavior any longer, okay? So essentially, React will keep on executing the fetch method, and it will keep on running the same API call again and again. Whether or not it has new data, you cannot control that behavior, or essentially you are not controlling that behavior, all right? We won't say empty, we will say not specified. Okay? Basically, you are not specifying your array itself, all right? Then there is a situation where the dependency array is empty. So that means you do specify it, but there is no value that is specified within the dependency array. So that means you would have a syntax which will just have the third brackets of the array and no value within it, right? So this will call, or this will execute the API call. API call executes only once. Okay, so what this means is that after the first time this particular application loads here, mounts here, it executes the side effect hook, right? And then within the side effect hook, it executes the API call once, and then it comes back to check whether it should execute it again, right? And the way it does it is based on whatever value is specified within this dependency array. So when it comes to that location, it sees that the dependency array is empty. So there is no value to track for React that will allow React to figure out that, oh, there is a value that I'm tracking, and every time this value changes, I need to go back and call my callback function here. Well, there is nothing to track. So if there is nothing to track, I have done my job, it's time to stop, right? So that is what this empty array means, that you're telling React that, hey, there is nothing to track anymore. So the dependency behavior that is associated to this callback function is done, and you don't need to execute this anymore, right? So that is when the dependency array is basically empty. That is what essentially it means, right? And then the last situation is when the dependency array has some value that you have specified, some value or some reference to an object or a variable, right? And what you're telling React is when you supply this. So let's say what we can do is we can create not an int, sorry. Let's say we can create a counter. And every time this counter value is updated, and let's say we can connect this counter to, let's say, an HTML button. So every time the user presses the button, the counter value increments, right? So the state of this counter variable changes. So what I can do here is that if I take now my dependency array, and instead of leaving it empty, what I do is within this particular array brackets, I specify counter. So what I'm telling React is that this callback function's execution is dependent on the state of this counter variable. So every time, now React can monitor this counter variable because it will be initialized with our useState hook, right? So it will control the state itself. So what we're telling React here that, hey, every time keep a track of this counter variable, that is your dependency array value. And every time the value of this counter changes, you need to go back and execute this callback function, which is going to make a call to the third-party API that is specified within the body of this function itself. Okay, so that is what this dependency array is going to keep a track of. You can even specify time periods here that, okay, if 1000 milliseconds passes or 1 second passes, execute this again. So this is the way, these are the three different ways in which you can control how this particular API call will get executed. All right. So the way that we are going to be doing here is to basically use the second way, which we know that this API call is going to send us a bulk load of data. So all we are going to do is execute this useEffect hook once after this custom component loads. Remember, useEffect hook will not execute before the rendering of your UI. First, your UI renders, then your hooks are initialized, and then it goes and checks, depending on the parameters that you specify, whether or not it needs to run those hooks again or not, right? So what we are going to do within our return statement is we are basically going to take this particular body, and essentially we will write a very simple application where we will create, let's say, a div container. All right. And within the div container, we will take this state container that we have specified here, which will receive the data from the API call. And we are just going to render that on our UI, whatever that information is, right? But remember, before rendering anything on the web browser itself, we need to convert that into JSON format if it is not already done so, right? And I know beforehand that this is going to return the data in just plain object notation. So before we can render that object notation on the web itself, on the web browser itself, we would want to kind of change that or translate that to JSON format. So it can be rendered on the UI itself in a much more structured fashion. Okay, so we are going to use this new HTML environment that is the pre-formatted environment. Okay, so we are not using paragraph here per se. We are using an environment that is called the pre-formatted environment, which we kind of write it as this, right? And within this, we are going to make a JavaScript code execution, not a JSX code execution, but a JavaScript. So we wrap it within these curly braces of the JSX syntax. Then we are going to make a call to our JSON package. And within the JSON package, we can see that there are two different methods. We can parse it or we can stringify it. And stringify is where we kind of translate any kind of basic JavaScript object into JSON notation itself. So we are going to stringify it, and stringify is a method. So it is going to take a parameter. So what are we trying to transform? We are trying to transform all the data that will be present within this particular data container, which is tracked by our state management. So we are going to dump that. Okay. And then there are some other parameters that we have to specify with respect to the stringify objects. So that is how much it is going to execute and to what extent, depending on any kind of precision that can be present there or not, right? So this is basically the plain and simple stuff that we have here. And you can, for a sanity check, what you can do is you can put some initial values here and you can check that if you have to put an object, please keep that in mind because you're performing stringify here. Otherwise, it will kind of mess things up. So you can just do a sanity check depending on the fact whether this works or not. Okay. So once this is done, we can save this. It's all good. So now we can go back and actually make that API call, which will be wrapped within the useState hook, right? So to bring the useState hook, the first thing that we are going to do, call the React package, and from there, bring in our useEffect. That's the hook that we want to use. It's a method call, and the first parameter is going to be a function call. So we are going to write it as an arrow notation. So this is the parameter. It will be fed into a function body. So the function body will be wrapped within curly brackets, because essentially that is how we are going to call the, or we are going to write a multi-line function. So we need to wrap those multi-lines together. And then the second parameter of the useEffect hook, we know for a fact, is going to be the dependency array, which we will leave it as empty. So when React comes and takes a look at this dependency array, notices that there is nothing to track, which is controlling the behavior of whatever we write within this function body, React will stop executing this after it has done it once. So in the first execution, when React executes this for the first time, it doesn't check the dependency array. When it comes back again to see whether it should re-execute this process, then it checks the dependency array. So the first time, remember, there is no checking for the dependency array. And if you do not specify this dependency array, okay, this keep on running again and again, so that every time there is a re-rendering, React will execute this API again. So even if the API doesn't bring any new data and the state doesn't changes, so as a result, you might see that there is no re-rendering taking place because the state has not changed. But the best practice is if you know that you're not going to need that API call more than once, then might as well you should use an empty array to signify that we just need this once. Okay. So now all that remains for us is to specify the logic of this guy here. That is what is going to be that API call. Okay. So in order to do the API call, as we discussed, we are going to use the method fetch, and fetch is going to basically take a parameter, which is going to be the URL of our Star Wars API call, right? So the URL that I'm going to use, I have a pre-formatted URL here. Well, this is the Star Wars API. So this is SW Star Wars API and then development API. And what it is referring to is basically the list of all the characters that are present in Star Wars itself, right? So if you give some numerical values here, it will bring you the first object that is present within this API, and so on and so forth. If you leave this empty, it will fetch the entire object list and it will bring it within your application, right? So remember, once a fetch is executed, this is just going to establish the connection. What you have to specify are two more logics. That is, if this is successful, what are you going to do? And if this is unsuccessful, what are you going to do? So anything that is successful, you're going to chain to this particular method call using the then method. Okay. So the then method basically specifies the successful execution of this API call. What is it that you're going to do? So the then method is also going to take, again, a callback function, but this callback function is essentially with respect to the response that will be sent by the API. Remember, when we wrote this API here, right, we said that a request will be passed to the API, an HTTP request, and then a response will be sent by the API itself, right, with the data, and the response will have some sort of data and stuff like that. Okay. And the request, you can also specify any kind of parameter that you are trying to send it. Okay. So the request was established by this fetch method. Now this API will respond back with some sort of data. So that is what you have to capture within this then call. The execution of this then is essentially going to be responsible for grabbing that piece of information, right? So the then function, callback function, is going to take the response parameter of the HTTP response call, okay? And it is going to pass into response.json. So that is, it will take that response, just like we did here. We transformed the basic objects into string notation, just to be on the safe side. You want everything to be in the JSON format. So here we're taking whatever data is being sent by the API call, and we are converting that into JSON itself, right? So this is again a method call here. So this is going to remain as such, okay? So once this is done, once we have converted the data, the response data, into JSON format, now we need to strip that data and we need to bring it inside the container, which has been declared within our custom component, right? So the next step of a successful call, once the response has been converted to a JSON object, is to call the then method again. And within this then method, we need to take data, we need to create an iterator. So this is a simple iterator that we are creating that will go over all the list of objects that is returned by this response. And then we need to pass this into the body of a callback function. But where are we going to save this data? We have already discussed that we want to save this data inside of this container that we have declared within our state management. So in order to update the value of our container, we need to use the setter method. We cannot simply just assign the data when we are performing state management. Remember, we have to use our setter method, right? So we are essentially going to call the set method or the setter for this particular state management. And we are going to pass as an argument this particular iterator, which will go over all of the different lists that is present in this particular response packet. All right. So I hope that makes sense. So we are going to take this set Star Wars data setter and then pass to it as an argument the iterator that will go over the list of objects or whatever data entries that is returned by the API call. So now we have taken care of the successful aspect of the execution of this API call. So all that remains now is to take care of the other side of the spectrum, which is what happens if this API call is unsuccessful, because sometimes you might not be able to reach out to the server might be down, you might have poor connection on the client side. There could be multiple reasons why this call might fail, right? So, and not just stuff like wrong code or incorrect code itself, right? So the last thing that we have to do is call the catch method. The catch method is going to wrap the logic of what will you do if your API call is unsuccessful, right? So the catch method, again, is going to take a callback function as an input. This is the domain where you will see only callback functions or functions being passed in as a parameter to other functions. So it will create a parameter called the error parameter. And depending on what is your error logic or how you're handling your error handling logic, you can write custom logic and stuff like that. But typically, it will be to give the client some sort of a prompt that, hey, server is not reachable, or whatever the error request code is. When you're dealing with server, when you're working with full stack development, you will see that there are many different server codes. For example, you might have seen 200 is for OK, 404 is for page not found, 500 is for internal server error. So there are different codes. So what people generally do, or what developers generally do in an error situation like this, they kind of grab the error, because when a server sends a response in the packet, it also sends within the header of that packet the server code, depending on the success, the unsuccessful behavior, and so on and so forth, right? So developers generally take that code and they make a custom message and they prompt that back to the user in a more presentable fashion, right? So in order to kind of mimic that behavior, we don't have a server side here, so we cannot grab the code per se. Okay, so what we are going to do is we are going to set up a simple console log message, and we can just say some sort of error took place. Okay, we'll just give some message so that we kind of know that, something like this has happened. All right, so we will save this, and once it gets intended, this kind of becomes better, right? So some sort of error took place. And then what we can do is we can refer to our error object here so that it understands, or it will just print out whatever log is being captured by this error object from this unsuccessful server execution environment, right? So this is basically the setup. So what will happen here is the first time that this custom component is loaded or mounted on the web browser, it will execute this div environment. So initially, you will not see any data because the initial state is empty. So once the state, the next thing that will happen is it will come back, it will initialize the state, it is empty, so there is nothing to see here. It will come here, it will see that there is a useEffect hook, so it will monitor the behavior that is happening inside. It will execute this callback function. Depending on whether it is successful or not, it will either execute these two chained then methods, or it will execute this catch method, okay? If the catch method executes, your application has at that point broken itself, right? So there's nothing to do there, right? However, let's say if it is successful, it is going to take the response packet that is coming from this URL. It is going to convert that into JSON notation. Then it is going to take the data iterator. It will iterate over all of this response data that is sent by the API. Then it will call the setter for the state management that we have established, and it will pass that data one by one such that this container can start getting updated by the data that is sent by the API itself, okay? Once that is done, the state of this particular container changes, which is referred to within this JSX syntax. So if the state changes, React will re-render your UI, so you will start seeing the new data, okay? Once that is done, React will come back and ask itself whether I should execute this logic again or not. So in order to do that, it will go check the dependency array. Since the dependency array is empty, that is basically telling React that, oh, there is nothing to track, which will allow you to figure out whether you should execute this again, or in a manner of saying that, hey, there's nothing to track, so you don't need to worry about this body anymore, so you don't have to execute this anymore. So once React encounters that area or that portion of the code, then it will stop executing this behavior altogether, and you can continue with your execution, whatever the rest of the logic is going to look like, right? If I had given some sort of a state variable here, let's say like a counter or something like that, as we were discussing somewhere in this application, like this one, then every time the value of that counter changes, React is going to keep a track of the value of the counter, which it can control. And since it knows that the counter, this execution of this useEffect hook is dependent on that particular variable, So React can initialize the execution of this external behavior every time the value of the variable or the object that it can control changes. That is how you give control or power to React over external behaviors. And that is why it's called a side effect, because that is not successfully coming or specifically coming from within its application itself, its component itself, but it can still control that behavior. Okay, so I hope you are able to kind of visualize how the logic of this particular element works, right? So now, once everything is set up, we need to go to app.js. First and foremost, we need to make a call to this, whatever the name of this is. So I'm going to minimize this. So it says React API tutorial. Okay, so I'm going to bring here within this div, I'm going to make a call to React API tutorial, and this should import it as well. Okay, so we're going to save this. Looks good. And if we go back here, we can see that initially this thing is empty and it's not generating any calls here, because here we go. So it took some time because the API response was coming back. But notice a few things that just happened. If you were paying attention, initially this was empty. You just saw just an empty bracket when I refresh this page, or when I just open this page. So what happened there is, because the state was empty, again, to recap the whole process, because the state was empty, this is what you saw, and this is what the browser rendered in the first go. So it referred to this particular container. This container is empty. Then it came here and it executed this without checking any conditions. So it tried to establish some connection. It took some time because now we are connecting to an external API. So there was this lag when we saw that, okay, there was no data that was being showed here, right? So the next thing that took place is that once data was responded by that API, let's say we can call it as a server, okay, so that we generalize and understand that this can be connected to a server and not just APIs itself. Your server itself is an API at the end of the day, if you design it as a RESTful API, okay? So once the data is received, we convert that to JSON, and then we iterate over that using an iterator. So it's a list of data objects, right? And then for every item within this data that is returned by the API call, we are going to call the setter of the container, which is being rendered on our UI. And then we are going to pass in as an argument the data that is sent by the server itself, okay? And every time the state of this guy changes, okay, that this container changes, React will by itself re-render the UI. Okay, that is the power of state management, because React has control over it. And if React notices that there is a change in the value, it will refresh the UI without you or the client having to refresh the page. Okay, so that is a very powerful component. And that is why you have this snappy feeling that you get from developing React apps, because it's not reloading the whole thing. It's not reloading or reestablishing connection to the server again. It's just changing whatever values are changing, and it's just re-rendering that portion. All right. So it keeps on rendering this data one by one, and you can see that this is the entire list of the people that is captured in the Star Wars API. All right. And then once that is grabbed, what it does, it goes back, checks the dependency array, and the dependency array is basically the values that React can track. And if those values needs to be tracked, then depending on whenever those values changes, React will execute this API call every time there is a change in value of whatever it is tracking. So it comes here and notices that there is nothing to track. So it forgets about this particular block of code, because it knows that it does not need to execute it anymore, only once, right? So that is where this execution ends, and we are left off with this particular situation. Okay. So I hope this is clear. This was the last component, and this is where how you will connect to your servers when you're working with a React UI as well. Okay. All right. So any questions, please feel free to ask me at any point of time. If not, I will go ahead and move on to kind of wrapping up our meme generator app. Now that we are aware of all of these different, or these three different main things that we need, which is basically React state management, React API call using useEffect hook, and then basically React event listeners and React HTML forms. Okay, not HTML forms, we'll just call it React forms, because the behavior is a little bit different, right? So we already have this memes component that is ready for us. Exactly that is what we need to use within this particular component. So what we need to do, first of all, is follow the same logic as we did with the Star Wars API custom component. Create a container, set up its setter, which is going to receive the data of all the meme images from this API that we are going to connect to, which will send all of these random meme images and stuff like that. We will set up a randomized function call so that whenever a user clicks a button, so let me just refresh your memory here as to what the objective of our meme generator app was. So the structure of the meme generator component, the main component that we will have is that there will be two input text fields. The user can enter the top text and the user can enter the bottom text. Then there will be a button that will be provided to the user. And every time the button is clicked, we will make an API. Well, we will make the API call before. So what we will do is we will make an API call at the beginning when the app is mounted. And what this API call is going to send us is basically a list of images. Okay, so whenever a button is clicked by the user, we will wrap this list of images with a random call, okay, or a random number generator. This button will activate the random number generator, and the random number generator will generate a value within 1 to whatever the total number of images that we have grabbed here. So let's say if it is 100, this n is going to be 100. So whenever this button is clicked, we will generate a random number, and then from the list of images, okay, which could be in the form of an array, we are going to grab that particular index and bring in the image. Okay, so now we have the top text, which is given as an input by the user. We have the bottom text, again, given as an input as the user. And whenever the user clicks a button, we generate a random number, which lower bound is basically, well, the upper bound is basically the total number of images that is returned by our API call. So we take that random number, we extract that from the list of images, and then in the final display, we are going to display the image, okay? And then we are going to display the top text, and then we are going to display the bottom text, okay? So that is basically the functional objective of how we are going to design this application, right? So now it should be pretty straightforward now that we understand what is the logic of the code and stuff like that. So let us just go through it and let us just code and get all the different states up and running, okay? So the first thing we are going to do is set up the container, which is going to grab the data or which is going to receive the data first. All right. So the way we are going to do it is set it up here within our custom component here. So here we will do state initialization. That is the first thing that we are going to do. Initialization. Okay. Sometimes we forget. All right. So now I'm not going to do it step by step. I'm just going to write it as a normal code in order to give you guys a little bit more confidence. I'm hoping that you understand the basic structures at this point of time. So we are going to set up a state. Again, state has a container. State will have a setter function. Okay, so I'm going to call that meme because it's going to give me back a set of meme images. All right. So what we are going to do is we are going to call the React library, and from the React library, we are going to use the useState method in order to initialize this process. And what we have for the initial state are basically three different keys. Okay, the first key, we will call it as a top text. So that will basically grab or store the value of the top text. So we will give some sort of a sample string. You can leave it as an empty string. The reason why I'm giving some value is to do a sanity check, because the first time this application is going to load, I want to see what it is going to look like, right? So that is why I'm giving some sort of testing values to make that happen. But once you're sure that that this is exactly how it is going to behave and that is behaving as you expect it to behave, then you can just leave this empty so that the user don't see anything unless they start to interact with your application, okay? Or you can give them some leading text in order to understand what is happening, okay? And then we will have some sort of a random image, and then we need to give some sort of URL. So you can give any image URL here from Google and stuff like that. So I'm going to do the same thing. I'm just going to grab a URL. Basically, this is the API that we are going to call this website, wherever this is. So I'm just going to grab a URL. In your case, you can give any URL that you want as long as it is a picture. That is just fine, right? So you just need to provide that URL from your from using this HTTPS directory. So once this is done, this kind of takes care of our state management itself. So the next thing that we need to do is kind of set up the array location. Okay, so this is basically the container which controls the information that will be provided by the user. So remember, this state initialization is for user-based data taking place inside the React app environment. Okay, and the reason why I write this documentation, this comment, is because this will clarify where we are going with this next, because we need a state initialization, or we need a state initialized container to store the data coming from the API call itself. So this is what we need. This remember, we will make an API call that will send us a list of images. That is what we discussed here, right? That there is going to be a list of images here. So this top text will be stored somewhere, this bottom text will be stored somewhere, and whenever the user clicks a button, whatever image is returned by this particular event listener function call, that will be stored somewhere. So that is what we generated here. This is the state for those three values. But remember, there is an API call that will take place, and that API is going to send us a list of images which needs to be captured within an array. Okay, so we need to have another state container which will be able to do that. All right, so that is what we are going to do now, is we are going to create a state container here. So I'm going to destructure this array, and I will say this is called all memes. Okay, and then I'm going to set up a setter, and I will say set all memes. Okay, so this is what the two things that it will return us. And then we are going to call the React library, and then we are going to call the useState method, and then the initial state, just as we did with our Star Wars API, we are just going to leave it empty. But this time we know a list is coming through, so we will be storing that inside of an array, right? So once these two things are done, then we have to initialize. I keep forgetting the spelling of initialize. Initialize API call using the useEffect hook. All right. So just as we did for the Star Wars API, we are going to do the same thing, like almost 90% the same thing. We're going to use the same set of syntax. Okay. So in order to call useEffect, how do we do it? We call the React package. We call useEffect method. It's a method, so we will have the first brackets. Within the method, two parameters, as we discussed. First one is going to be a callback function. So whatever parameter, pass it to the logic of the function. Second parameter is going to be a dependency array. So we are going to leave the dependency array empty because we don't want this to rerun again. We just want the bulk image in one API call. We're going to bring it in, and then we're going to execute that, right? So once this is done, we can basically stop this here. And now within this function, callback function body, we can basically execute the call to the API itself. So we are going to call the fetch method, and within the fetch method, we will pass in as an argument the URL in string format of the meme. So the meme URL that we have is this one. This is the API that we are using from image flip. So we are going to call the get memes API. We are going to work on that. Okay. So once we have established connection, we have specified how to establish the connection. What is there to do next? Well, what happens when it is successful? So successful code goes the same. We make a then call. The then call is going to have a callback function, which will take the response packet that is coming from the server, convert that into JSON. Once that conversion is done, we need to basically update the state. Okay, so we need to call our then method again. Within that, we will have another callback function where we create an iterator that will go over all of the individual data in the list of data. And then every time it visits a new data, it will call this setter, and then it will essentially take that particular data object. Now, I'm going to take a few steps forward, and I'm going to tell you that since it is an array of objects, we have to access exactly the meme information itself. Okay, so I will show you exactly what it is going to do. but we need a object call here because this mean information is actually present in the second index of the array that will be returned. Okay, so I will show you later on what this means. We will come back to this hopefully in today's class. If not, I will just revisit this and explain to you what this is doing. Because once you see the structure, I don't know if we have imported it here, but once you see the structure of the data that is returned by this, you will realize that you need to make these changes, the call here as such. Okay, so once this is done, the last portion is to basically catch any kind of error that might take place. So again, we take an error object and we pass that into a console log information, and then there was an error, and then you can say C, and then here you can just pass in the error object. So whatever the console log information is present there, it will basically grab it. All right, so that takes care of all of these chaining methods. Here we made a typo here. We forgot the dot operator to chain it. So this will take care of all of the different setup. All right, so if the fetch was successful, if you want to put a debugging statement here, what you can do is you can do a sanity check to test data was fetched, actually fetched, if you want to do it, because remember, we are not putting this out on the user UI or the UI itself as we did for the Star Wars data, where we could see that the fetch actually took place, right? So we are not going to do that here because the logic of our code is a little bit different. So if you want to do some sort of sanity check here, all you can do is call this container, which will be storing all of our information, and that will be printed on your console either here or it will be printed not here, it will be printed in the console of the web browser itself. So there you can check if it was fetched or not, right? So this is basically like a sanity check to double check that it's happening, because sometimes what can happen is that could be a successful call, but it doesn't return you anything. There are situations I have encountered like that as well. So in order to kind of avoid those situations, we need to set this up. All right. So in addition to that, we know for a fact that there are going to be two event listeners that we have to take care. One for input text field, and then another for clicking button to generate images. So we know that there is going to be two different types of event listeners, which will be tied directly to this particular state container that we have, top text, bottom text, and images. So we will come back to this event listener once we have filled out the body of our application. So here I'm going to delete all of this unnecessary stuff here. So let's say we make a change this time and we create the main body. Okay, remember we use the HTML main syntax. So this is what we are going to use here. You can no problem use a div container. There's no issue with that. You can continue using the div container if you would like to. So the next thing that we are going to do is create a div container around our form input. All right. So here I'm just going to say that I'm going to give it a class name in synchronization to the CSS form that I had already pre-written. So I'm generating this class names for those purposes so that it kind of applies the syntax there. Okay. So the next thing that we are going to do is set up our input field. So here, as we discussed, we have this input field, we have this input field, and then we have this button. So within this div, I'm going to set up these three form fields, and then I'm going to write down the event listener logic that will be executed whenever there is an event that takes place on this particular. So this one is going to be on click because this is a button, and these two things, which is a text input, is going to be on change. And if you do not recall what those two things are, you would want to revisit the previous lecture and go over the discussions of event listeners from that particular lecture as well. Okay, so I'm going to set up an input field, and the input field is a self-closing field. And then after that, we are going to express all of the different attributes that we will have for this particular input field. So I'm going to type out one, and I'm going to copy paste the rest because it's exactly the same for all of this. So if you understand the structure of one, you will be able to follow through the structure of the remaining one. So it's going to be of type text. It's going to have a class name for our CSS file. So I'm just going to give you a class name of form input. That's the class name that I use. If you need to show the user some kind of placeholder information once your app loads, so you can say top text here or whatever message that you want to give to the user. You need to give it a label, because when your event listener gets executed, this form field will be identified by the label that you provide here. So I'm going to provide it with the top text label. Okay. Then when the event listener gets executed, it also needs to grab the value. Now, we don't want to statically hard code our values. When we set up our form elements, we want to refer to the container, the state container, which is keeping a track of the value. So here, notice that this container keeps a track of the 3 values that will be updated by the users. So whenever we set up the initial value of our form fields, we want to tie up the initial value of this form field to whatever the initial value of the container is. It could be empty, it will show sample, whatever it is, right? But do not statically hard code. That is not a good practice. So all we need to do is refer to the container, which is basically this meme, and this is an object, right? So we will do meme dot top text in order to access the particular key value. So here we will do top. Oh, that's not how you write JavaScript. You will do top text. Okay, so that will be the initial stuff, and then we will need to set up an event listener. That's the final piece of the puzzle. So the event listener is going to be on change because there will be a key press. So any kind of change that will take place will be referred here, and it will execute a function. So we will call that function something like handle change, right? So this is basically how you set up the form field. Okay, so now we need to write a function here. So we will put this function call here, and this function call will be named handle change itself. So we will leave this now, and it doesn't need parameters. We will call it the event parameter, which is referred to as E, and that is what we will use. And then we will set up the next input field, and it is going to be exactly the same, but with some changes to the values here. So I will dump this here. Okay, so this is for the bottom text. So you only change the different fields wherever you need to make a bottom change. So we will reinitialize the state container, but it will refer to the same function here. Okay, so finally, what remains is basically to set up the button. So in order to do the button, okay, the button is not a self-closing tag, so we can give the button here. And notice the fact that since this is self-closing tag, it will not have any kind of label data, right? So the only information that you will see is from the placeholder. So if you want to give a label, then you have to set up a label field itself. So refer to the previous lecture in order to see how that is done. Okay, if you do not remember how to do it. So we will set up the button environment, and the button environment will give a text. So we can say select a new meme image in random, something like this. All right. And now we have to kind of do the same set of things that we did for the other stuff, is that we give it a class name. So we can say that this is a button for our form. Okay. And then finally, we need to give it a event listener. So we are going to say, what should you do when this happens? So we are going to say get meme image. Okay. So when this is clicked, this will execute another callback function, event listener function. So we will say that the name of that function is going to be get meme image. Okay. So get meme image. And this is also going to take the event parameter object as input, and it will execute some sort of logic, and we will come back to that, right? So the last piece of the puzzle that remains, I keep on saying last and last, but you know, it is never ending, so to speak, right? So what we need to do after this is, as we see here, we have taken care of this div environment. Okay, we have set up this div environment, albeit we still need to write down the logic of the event listeners, but you can see that there is going to be another output section here. You can write this as a separate component if you want, but I'm just going to take care of this in this particular component itself. So we basically need to print the image, basically need to print the top text, and we basically need to print the bottom text, right? So that will be essentially done in this particular section here. So I'm just going to create another container, which is going to kind of wrap around the output section of our application. Let us give it a class name because I think some CSS is associated with it. And we're going to leave it empty for the time, right? And the reason why we're going to leave it empty, because we should first of all take care of the what do you call it? The event listener logic first, and then come back to this. Okay. So let us look at the handle change. Remember, the handle change is for the text inputs. So what we are going to do is we are going to first destructure the event parameter object by taking out the name and the value that is wrapped within the event parameter. Okay. And the way we are going to do it is by accessing the event parameter E and then its key that is known as target. So all we are doing is basically we're extracting these values and storing them in their individual containers. So once we have extracted them, all we need to do now is to basically update the values of top text and bottom text that the user has provided and override the initial values that has been provided here, right? So all we need to do now is make a call to the setter. Okay. So what is the setter here? The setter is set meme. So we are going to call set meme. Where is it? Here. Okay. And this is a setter. So it will take some arguments as input. So the argument is going to be a callback function because we want to preserve the previous state of these containers as well. Okay. So we are going to set up a parameter here and let us call that parameter an iterator that is known as previous meme. So we can keep a track of all the changes that has taken place. This will be fed into a function body, and that function body essentially is going to wrap the logic of the method that will stay within this particular function, right? So that is going to be the spread operator. Remember, the 3 dots is a spread operator. It is a way of pasting all of the content that is present in whatever follows this spread operator. So we are basically pasting all of the contents of the previous meme. Okay. And after that, what we want to do is we want to, depending on the name of the event or where the event is called from, remember we have a label there. We want to refer to that, and then we want to pass whatever value that has been given here to that particular event itself, right? So once that is done, that kind of takes care of this kind of this particular function call, and it takes care of our handle change. Pretty simple. We just extract the name and the value of the from field, which is calling this particular event listener function. Okay. Then we call the setter. We pass in the previous state of the container into the function body. We paste the previous state of the container. Okay. So that we don't lose it. We don't overwrite it. If you do not do this, if you just do this much within this particular parameter, then you will overwrite the previous ones. If that is what we want to do, then that is what you do, right? But if that is not what you want to do, you want to preserve the previous state, then you need to perform this operation here. Okay. And then finally, we just see what particular field, is it the top field or the bottom field? Because notice here, we have given exactly the same name, which will relate to the name or the keys of the state containers. Okay, so that this name will directly connect to that particular name, right? So that is how this is going to work. All right. And then the last piece of information that we need to execute here is basically the logic of the button itself. So what happens when the button is clicked? Okay, so when the button is clicked, there are two things that we need to do. We need to set up a random number generator. We need to take that random number as an index to the array that stores the API call. And then we need to update this guy here, which is storing the URL of the random number generator. Okay, so that is basically the logic that we are going to execute. First, create a random number. Second, use that random number as an index to the array. This is the array that we are talking about, which is storing the list of images. Extract the URL from that array, and then call the setter of this container here, and then update the key value pair, which will actually store the most up-to-date URL that you are dealing with on your UI. So it's a 3-step process or logic that we are going to execute in this particular scenario. All right. So for the sake of time, I'm just going to copy that piece of information here. And then we can talk about what we are doing. So this is going to be pretty straightforward. Okay, even though it's not that difficult. All right. So what are we doing here? We are generating a random number using the math package of your JavaScript, right? So what we are doing, first of all, we're taking the length of the array that is going to give us the upper bound of the random number generator. All right. Then we are calling the .random function within the math package, and they're using floor. I'm hoping that everybody understands mathematically how floor and ceilings work, okay, in terms of data type. So we are just taking the bottom side of the random. So if you have 65.2, this will return 65. That's what floor essentially does. So we are storing that value here, okay? And then we are creating this variable, which is URL. And what we are doing is we are using the random number that was generated in the previous step as an index to the array, which is storing all our memes from the API call. And we are extracting, since it's an array of objects, okay? So that means this array index, we are extracting the URL and we are storing that URL in this local variable to this particular function, okay? So once we have extracted this URL, you can notice here that we have saved this URL within this particular state container's random image key, right? This is where the initial URL was, right? So what we are going to do is we are going to call the setter, okay? Paste all of the previous URLs that was basically tracked by our setter or our state container. And then we will update the random image, which is basically this particular key, with the new URL, which is stored in this temporary container that we have extracted from our array of objects that has been populated by an external API call altogether. Okay, so that is basically the logic of the application. All right, so now all we have to do is, now based on that, we need to fill out this guy here. We haven't forgotten about this, is that we need to set up an output image, right? So when we set up the output image, we will have an image tag. Image is a self-closing tag, so we're going to set it up like this. Image needs to have a source. Now the source will not be hard-coded. The source needs to come from where we need to basically refer to this container here, and whatever the most up-to-date values within these containers are going to be, that is what our result is going to be as well, right? So all we need to do is, where is it? Okay, here. So all we need to do is we need to first of all, oh, not this. Where am I? Oh, we're making a mistake here. So we need to go inside this div container. I created this, and all right. So here we need to wrap this inside curly brackets because we are going to do a JavaScript code here. So we are going to refer to the state container meme, and within the meme, we are going to refer to the key, that is random image, in order to specify the value. Then we can give it some class name. The class name is for CSS purposes here, specifically speaking. So the one that I have used here is meme image. And then we will give some sort of an alt text, and we will keep this empty. All right. And then we need to have a top text and a bottom text. So the way I'm going to specify the top text and a bottom text, you guys are free to use any HTML element that you want, any heading type that you want, heading hierarchy. So we are going to set up an H2 header for ourselves. We're going to give it a class name, and we're going to say it is going to be meme text top. Okay, that's how we're going to write it, with a space, because that sets up the hierarchy here. And then what we are going to refer to here is basically whatever information is present within the meme container for top text. So we are going to do this, and then we are going to copy this guy here, paste it again here. But this time, instead of doing top text, we are going to do bottom text. And here we will replace this top text with essentially bottom text itself. And then we will just save this. Okay, everything kind of looks good. So all we have to do now, all that remains, is we have to come back here to our main app.js. We need to call this meme function here, because you can see we have the header call, but we don't have the meme call. So we will just go right below here, and then we will just do meme. Okay, and did it import it as well? Okay, so it imported it as well. Everything looks good. Compilation is successful. And then we can see here that this is basically the initial, what do you call, stuff that is given here, right? So once that is done, and once you create an array, we have an error somewhere. So we will have to process this error. So all memes are undefined. All right, let us just check that error real quick, and we can come back to here. So we have a runtime error. That is the worst type of error to deal with. So let's do some debugging. So where is all memes? Here is all memes. Okay, so can you guys see and work with me and see if why it is saying that it is undefined? Although we don't get any errors here. Any ideas? All right, let's work on this. Let's see what is happening. Please feel free to chime in anytime if you have any kind of questions or if you notice any changes that might be leading to this error. So let us look at the message real quick. So it just says all means is undefined. Okay, let us refresh this page. All right. Can we get any kind of information from our stuff here? This is not going to give us anything. We essentially need to be within the console. So our array is empty. An array is empty. And then this is undefined. So is it that our API is not working? That could be a reason for that. But then it should return us the error. But the error what we get is all memes is undefined and not something else. It always refers to all memes is undefined. All right, let's start debugging step by step. Where do you guys think we should start? Any ideas? Anybody
Nope.
online?
No idea.
Okay. All right, let's remove this console log and let's see what happens first. All right, so the console log is giving us an undefined, so it will still give us an undefined as well. All right, but now we have get meme image. All right, so it is giving us the error within get meme image, I think. So let us check get meme image first. Where is our get meme image? All right. So we have this guy here, which has been declared here. I think this is where the problem is happening. I need to double check on the format of the data again. Because this seems to be a little weird. All right, I think I know what is happening here. So we need to take the data here, and then we need to call on a member variable, which is data within the object in itself, right? And within that, we have the array that is not meme, but that is, I think, memes. I think that is the format of the data. Okay, let's give this one more try and see what happens. All right, error. Okay, so I'll tell you what happened and I will explain essentially what the mistake was. All right, so I told you here that this is basically an iterator that we are creating, right? You can name this iterator differently. Let's say in order for you guys to understand, let me just change this iterator to something called item. So the item can go over the data itself, right? So basically what is happening in this particular situation, I don't know if I can download this single file separately or not. Okay, I cannot go here, but look at what is the state of the data. Okay, so this is what the data that is being returned. All right, so you see from lines 2 here, okay, going onwards to the end of the data set here, this is what the API returns us, right? So that means this is basically an object that will be returned to us, which will have a first member, which is going to return that success is true, which is the response from the server. Okay, then notice that there is a data key within which the data key has a value, and that value is basically an array of object itself. All right, so that means when we get this response, this whole response, this is not exactly what we want, because we need to first avoid this. This has nothing to do with the functionality of our app. You can do whatever you want with this, but not with the functionality itself. So the actual data is in the second key, which is called data itself. This is coming directly from the server. Okay, so we are not in control of this naming convention. So once we set this up, we have to get to this data key, and this data key has an array, which is called memes. And then this memes is everything that we have here. So if you understand this, right, now that you understand this, when we get this response, okay, we are dealing with everything that you see here. This assignment is a local assignment that I did separately to save the data locally, okay, test things out. But this is what the response senses back. So in this response, this is what this line is going to do, is going to take the response, convert it into a JSON, okay? Now, we have this object, and it's a list of data. But the list starts from here. But the data starts from line 2. Okay, so that means when we have to set up this iterator needs to start from this guy here, this array, because that's, you can iterate over the array. You cannot iterate over an object which has just 2 keys, right? Doesn't make much sense as to what you're trying to do in terms of the logic. So what we do is we take the iterator, then we access the key which has the list of data. That is what the important part is, right? So this is the data that we are specifying here in the second location. And then we need to access the mean array. That is, the name of the array is means. So the mistake that we had done here is that we misspelled this name, the name of the array, because we don't have control over how this naming convention works, because this is coming from the server. So we have to figure out what exactly is coming from the server. Okay. So anytime you hit an error there, and it's a runtime error, this is exactly how you need to debug. You need to figure out your specific situation, but you need to be aware of the metadata of the server. That is what the important thing is, right? So anytime you're dealing with some sort of a server developer, or anytime you're working with a third-party API, the very first thing that you should do before setting up all of these technical stuff is to kind of make sure that you understand the structure of your data, the metadata itself. Otherwise, you will hit errors like this, and it can take a long time to kind of overcome your errors, which is stuff like that. And the reason why you still see sample here is because we have to write some sort of text here, right? So we can say that this is, so you can see it automatically updates. That's the power of React. There is no refresh time. The moment it notices that there is a change in the state, this is the top text, it will start rendering. Okay, and then here you can say this is the bottom text. What would have happened here is, if you had an app that is not React based, okay, Vue can also do something similar to React as well. But if you had a plain app, right, like vanilla script app, then essentially you would have to hit submit. That submit would have triggered the refresh of the page, and this side will reload essentially, right? But in React, you can see the moment I do some change, React, because I have done use state hook, it notices there is a change. So it notices that, oh, I need to start rendering this. Okay. And since this is an on change, so that means any change takes place here, any change is immediately rendered. Okay. And that's the power here, because you can see here, this page is not refreshing. This area is not refreshing. Just the portion which is being changed gets refreshed, right? But the moment I hit this is going to change things again, right? The moment I keep on hitting this, it will keep on changing this. The moment you type changes here, this will do some changes, okay? And this is basically CSS, how the formatting is done. So you can check out the CSS. We're not going to discuss the CSS all again, okay? So that's basically the power of React. So at this time, we will wrap up. Again, please revise. We have covered all the main fundamentals of creating a dynamic and interactive web app using a React JS framework. So those are the fundamental things. Of course, there are much more to React than that, but for the sake of time, we can't cover everything, right? So at least with this much tools, you can build a fully functional, interactive, and dynamic web application using React itself. So at this point, today, I will give you the homework for React itself. That will be the 4th homework. And after, as we are done finishing React Native, I will give the 5th homework. But remember, we're going to drop the lowest score. So for all those who will be satisfied with your first 4 homeworks, for them, doing the 5th homework is basically going to be optional. Okay. And you will have 4 more quizzes as well, but that is just going to take 10 minutes of your time, and it's going to be simple enough, and it will be due by the end of the semester itself. Okay. So please practice React. Please do the homework so that you get it. This is a very beautiful tool. It's a very powerful tool to learn. So make sure that you add it onto your skill set if you are thinking of a career down this line. Okay. So I will see you all again on Thursday with the starting of discussion in React Native to develop mobile applications. Thank you.